Good afternoon, everyone. Yes, I am glad to be here and to speak about the difficulties we may encounter, the knowledge we must have, and the outcomes we can get when using humus form for forest topsoil classification. I'm a soil scientist and I'm a humus form classification user. So I will speak about what is my experience. I thought about the difficulties, and I think that despite the previous presentation by Dylan, I think that describing and classifying humus form is easier than describing a soil profile. But if we take into account the fact that the organic matter component of the soil is much more dynamic than the soil mineral phase, then we can have a very large spatial and temporal variability in humus form. So probably, in my opinion, one of the biggest difficulties, the greatest difficulties, is to find what is indeed the representative humus form at the forest stand level. In the table, you can see some examples of variability. This was taken from during the biosol projects many years ago. And so it's the range of variation at 5 sites within a radius of 50 meters. In some cases, we have a shift from to a humus form to another one, but within the same humus system. In other cases, also the humus system changes. And this happens quite often with amphis forms. And if we think about the difficulties, then we can move to what, in my opinion, is the mandatory knowledge we must have. I think that we have to keep in mind that humus forms are the results of the factors of soil formation. And therefore, these factors of soil formation might have direct effect on humus forms, such as, for example, topography. Thinking about a slope will certainly, sites along a slope will certainly be different than sites at flatter positions. But the factors of soil formation will also have indirect effects by influencing all soil properties that in turn affect vegetation and soil organisms. And therefore, we have, in my opinion, to keep that in mind and use for humus forms the same approach as as we use when studying soil formation and soil profiles in general. If we keep in mind this mandatory knowledge, we have very nice outcomes when using humus forms because, for example, in the table there are all factors are kept constant in each column, and between the two rows of each column, only vegetation changes. And in this way, we can, first of all, record the variation in the topsoil caused by the presence, in this case, it's an alien invasive species in Italy, the red oak. But if we look at the different columns along the same row, we can also see how dynamics are humus form and how they can well reflect the different level of fertility at the different sites. When instead many factors vary, then humus forms are good and cheap indicators of environmental conditions. In this example, we have variation in tree species, variation in lithology, and variation in elevation. We are in the mountains, so it's also climatic conditions. For example, we can see the variation of humus form for the same species and the same lithology with climate, or in this case, we have the variation that depend on the different parent material for the same species and the same climatic condition. And the last outcome I want to show you is this picture, because we all know that humus form reflect the turnover of organic matter. So again, they are fast and cheap indicators of all things related to the turnover of organic matter, carbon stocks, and release of nutrients. These are the results of some incubation experiments, which are time consuming and also expensive. And this is the evolution of CO2 from organic horizons along 1 month. It's again for the two species of the previous slides, and you can see how well the difference in humus form, one was dismal and the other one a numimore, are reflected in the development of CO2 with time. The lower line obviously is that of the red oak and of the humimore. And that's it. And I'm waiting for your comments and suggestions. Thank you.